Hi, for those of you who don't know me, I'm Eddy Bruël. I am Rick's co-founder. We work together on Makepad. For those of you who haven't seen Makepad, check out makepad.dev. Makepad is a UI framework in Rust, and we're trying to do something new, which is live coding, meaning that you can change the code and the look and feel of your application will change to reflect those changes in the code while the application is running. Because we're doing that, we're also trying to write our own code editor. The main reason is that we want to have stuff like inline widgets inside the code, which is something you can't easily do unless you roll your own. So this talks about how would you go about writing a code editor from scratch in Makepad. So one of the first things you run into when you try to build your own code editor is that drawing text is hard, and the capitalization is very much intentional. One of the first problems is that in Rust, a string consists of cars, as everyone knows, but you can't just assume that one car is one character on the screen. No, what you need to do instead is work with grapheme clusters, and a grapheme cluster is a sequence of one or more characters that together represent one user-perceived character. So you would assume that one grapheme cluster then equals one glyph on the screen, right? Well, no. It's more complicated than that. So a single grapheme cluster can be drawn as multiple glyphs stacked on top of each other. So one example is the E with the dots over it. There is a variant in Unicode that draws that as one character, but the other option is that multiple grapheme clusters can be drawn as a single glyph. That's something that happens, for instance, with ligatures. And on top of all that, not all grapheme clusters have the same width. So Latin characters are usually 1 column wide, but things like kanji and emoji can be 2 columns wide. Tabs can be as many columns as you want. To do all this properly, you would need to use a shaping engine like Harfbus, which is not what I did. Instead, I tried to do something simpler. Oh, this is a fun read, by the way, if you want to read more on text rendering and why it hates you. There's a lot there, believe me, it's insane. So I've made a number of assumptions when writing this code editor. The first, that our code editor is line-based. That means, of course, that it only scales to a certain extent, but I feel like for most reasonable code files, it performs more than enough. We don't support proportional fonts because who does that? But more importantly, making that assumption allows us to lay out our text in a grid. And we don't support ligatures, which is also something you don't often see in a code editor anyway. And that allows us to assume that one grapheme cluster is either 1 column or more. So that's another simplifying assumption. And finally, I didn't even bother to look into right-to-left text rendering because this is already complex enough as it is. So I'm going to go quickly over the features we did try to support and how we went about supporting them. So first thing to understand is that our code is line-based. So internally, you have a vector of lines. So what is a line? A line has several data. One of that data is token information. So we want to support syntax highlighting. For that, we need to store a list of tokens for each line. So we represent that as a vector of token infos. A token info consists of the length of the token and the token kind. How those tokens are generated is kind of fuzzy right now. So for the demo, I hacked in a tokenizer that we already had. But eventually I want that to be pluggable, and I still need to kind of work out our plugin model. So that's a bit of a hack at the moment, but it does work. Another feature we want is inlay hints. This is something that Visual Studio Code also has. This allows you to annotate your code with things like type information that's generated by, say, Rust Analyzer. We also want that, so the way we represent inlay hints is by having a vector of byte offsets and string. So the string is the text for the inlay, and the byte offset determines where in the text it ends up. So that would end up rendering something like that. Like I said, we're building a live coding editor, so eventually we also want to be able to insert widgets in the middle of the text. For that we use another vector of byte offsets and widgets. a widget consists of an identifier and a column span that tells the code editor how much space to reserve for it. So the code editor reserves the space, but the drawing and the handling of events for the widgets happens outside the code editor. So that's not something I bother with right now. One problem with this, say we have a text inlay at byte 4, and we also have a widget at byte 4. Does that widget then up before the inlay or after the inlay? So there's an ambiguity there. To resolve that ambiguity, I've added a concept called affinity. This is something I stole from Xi. That's another Rust code editor. Thought it was clever, so. Affinity, it's just an enum that says whether the widget needs to end up before or after the inlay. So with that, we get the final representation that we actually use, which is a combination of byte offset and affinity for each widget. Then there's word wrapping. That's probably the worst feature you could ever build, and I wouldn't recommend you ever build it because it makes everything more difficult. We do want it though, so I did end up implementing it. The idea is that you have a couple of positions in your text where you add a soft line break. So it doesn't have an actual text representation, but it still breaks the line into multiple rows. I represent that simply as a vector of byte offsets where each wrap should occur. We want text inlays to wrap as well, so we want that to be part of the layout flow. So byte positions for wraps apply to the text with inlays applied. Not sure if that makes sense. So if I say I have a text of 10 bytes long and I have an inlay of 5 bytes long, then the text with inlays would be 15 bytes long. That's the idea. So our word wrap algorithm is very simple. We just simply try to lay out all the elements in a line one by one. If the current element does not fit on the current row, then I insert a wrap at that position and I continue on the next row. So it's really straightforward. Word wrapping should respect indentation. This is something VS Code also does, and it looks much nicer. But it should only do so if we can fit at least one element on each row. If we can't, then it ignores indentation. It just does everything on the first column. So for that, I have a variable called start column after wrap, which each row after the first will be indented with. If that sounds vague, it'll all become clear when I show the demo at the end of this presentation. So this is a feature that Rick originally thought up, and I think is very cool. We want to support animated code folding. So when I press a button, I want all the contents of the function blocks to fold into nothing, and I want that folding to happen with an animation. One problem with that is once you have animated code folding, now each line can have an arbitrary height. But we don't want to abandon the grid layout that we established earlier. So the solution there is we keep our grid layout, but we give each line a scale factor, which you can somewhat see here. The first row is higher than the other rows, and also the columns at the end are smaller. Oh, one thing I forgot to mention. So if you look closely, only the columns at the end are folded. The ones at the beginning are not. And this is because code folding also needs to respect indentation. So columns do not start folding until after another value called fold column. So with all that together, you end up with our representation for a single line. So there's the text for the line, there's the token information, there's the text and widget inlines, there's the wrap bytes, and whether the next row needs to be indented or not. And there's the fold column and the scale for each line. So that's what our line representation looks like. Does all of this make sense, or am I going too fast? Great. So a line provides 3 iterators over its contents, and the reason this is important is because this is how I end up drawing a line on the screen. So there's tokens, there's elements, and there's wrapped elements, and I'll try to quickly go over each of those. So the tokens iterator is simple, it does what you expect. It iterates over the tokens of a line. Each token consists of the token text and the token type. So how it works internally is it iterates over the token infos, which we already have. And then for each token info, it creates a token by borrowing from the text right? So the token info only has the length, whereas the actual token has the contents. The elements iterator iterates over the elements of a line. Now, an element I've defined as either a token or an inline widget, and a token can be part of some inlay text, right? So internally, this iterator uses the tokens iterator we had earlier to iterate over the tokens. It keeps track of where we are in our token stream. And then at each position, we check, hey, is there a text or widget inlay at our current position? If so, we're going to yield that one first. Otherwise, we're going to yield the next token. But if it so happens that there's a text inlay or a widget in between that token, that this is something that doesn't normally happen, but could happen during editing, then we chop the token up in two, and we yield those fragments one by one. So the end result is we get a stream of tokens, widgets, and inlay tokens. Once we have that iterator, we can define the final iterator, which is wrapped elements. A wrapped element is either an element, so again, token, widget, or an inlay token, but it can also be a wrap. So internally, this iterator iterates over the elements, again, keeps track of our position. If there's a wrap at our current position, we yield the wrap first. Otherwise, we yield the next element. And like we did with the tokens, if there's a soft line break in between some inlay text, then we chop that up in two as well. So with that final iterator, I can draw a line, and that looks somewhat like this. So for each wrapped element, I check, what do I have? Do I have a token? If so, draw that. If I have a widget, draw that. And if I have a wrap, then I go to the next line by incrementing y with the line scale. Remember that the line scale is essentially the height of a single row. And then at each step, I also increment the column. And from the column, I can obtain our final x position by calling column to x. And that applies the scaling that I explained earlier, where the first columns don't scale, but the later ones do. So that's how a single line works. From that, we can go to multiple lines. And this is something I call a document. This is essentially the same thing you've seen before, except now we're using a struct of arrays representation. Right? So for each field in a line, we now have a vector of vectors. So, like I said, struct of arrays representation. A document provides a lines iterator, and what the lines iterator does is pretty simple. It iterates over all these arrays at once and then yields a single line at a time. So now I can first iterate over all the lines in my document, and then for each line do the draw algorithm I illustrated earlier. So when you're drawing large documents, say 20, 50K lines, you only want to draw the lines that are visible, otherwise you're wasting a lot of work. That's somewhat tricky because not every line has the same height because of word wrapping, because of folding. So the idea is that for each line, we can cache the sum of its height and that of all the lines preceding it, with something I call summed height. Once you have that for every line, you can perform a binary search on summed heights to find the lines that are visible. That's interesting. My screen is lagging with... Oh. For scrolling, we need to know the dimensions of the entire document. Otherwise, you don't know how long your scroll bar should be, how far it can scroll. Computing the height is now easy because we already have the summed height of the last line. We can just use that. Computing the width is harder because you need to find the maximum width of all the lines. What I do right now is I do it the stupid way. I just iterate over all the lines, do a draw operation without actually drawing anything while keeping track of the number of columns. This could be further sped up by caching the line widths, but that's not something I do right now. So I had a final bit on selections. I'm kind of running out of slides, but I'll keep talking for a bit. So a selection consists of a cursor, which is the active end. So that's this part. That's the part that moves when you press something on your keyboard. And then there's the anchor. That's here. That's the part that doesn't move. And the part in between is what's selected. A cursor and anchor positions consist of a line number and a byte offset. Now, with cursors, I have the same problem I had with the widget inlays, which is that if a cursor is at, say, a soft line break, does it end up before or after the soft line break? Because both positions have the same byte offset. So that means I use the same trick I used with widget inlines, which is that cursors have an affinity. So final bit on cursor movement, that might be interesting. So it turns out that something simple as moving a cursor up is actually quite tricky. Because you can't just go to the previous line. You might be on, say, the third row of the current line because of word wrapping, and you want to go to the second row, and you want to find the same column. But the same column might not have the same byte offset because, like I said at the beginning of this talk, graphemes are not all the same width. So what I do in practice is I have two conversion functions. One can go from byte offset to row column position in the line. And the way that conversion works is really simple. I just do another layout pass of the line, and I keep track of which byte am I at right now, which row column corresponds to that. And then if I find the matching byte, I return the row column position that I need. And then I have another function that goes in the opposite direction. So what happens is I convert my column to my cursor to row column position, decrement the row by 1. Got it. Thank you. Decrement the row by 1, and then convert back to byte position. One tricky part there is, say we're now at this column, and I want to go one row up. Well, there's nothing there, obviously. So what happens then is I default to the last column on that row, making sure that my affinity is before, because if I don't do that, I end up here after the soft line break. Well, I have 5 minutes left, so this is probably a good time to start the demo. Yeah. So, this is what I have right now. This is still a work in progress, so forgive me if it doesn't look really good, but...
Can you unmaximize it?
I could. Would that help?
Yeah, because cropping.
Sure. Here?
Better.
Okay. So this is a 20K line document. So for some reason, Rick, the scrolling is crappier if I unmaximize it. So it's actually smoother when I full screen it. I don't know why yet. Anyway, so scrolling is nice. What's also really nice is if I press escape, you can see the animated code folding at work. Is that, I know I'm standing in front of the screen.
Yeah, so we're also
this helps.
recording this presentation through Makepad. So the latency you're seeing is actually my entire computer with 2 HDMI capture devices going through the screen.
Right. So that works. There's, of course, dragging. Oh, and I have multiple cursor support because, who doesn't have that? It's still a bit finicky because what you see here, I've marked it in red. Those are the inlays that I mentioned earlier. I can't select them. I can either select before or after them.
Yeah, so this is for type information generally used in Visual Studio Code.
Right. And of course, you can also use this for widgets eventually, but that's something I haven't shown yet.
Color picker and sliders are
the that's the idea we're working towards, is that say you have a color value somewhere in your text, then a color widget or a color picker would appear next to it, and you can drag and drop, you can drag the color picker to change the value of the color. And that's just one example, of course, like we have other ideas in mind there. Yeah, so that's what I have. Any questions?
Really nice. So, anybody?
Thank you for your talk. One question related to the rendering of the text. Is the rendering done on the GPU or on the CPU?
All GPU.
All GPU.
I can go in a bit more detail than that. So the rendering part happens in Makepad itself. What we do right now is we create a texture map of all the glyphs that we use. Those glyphs are rendered on the GPU using an algorithm I wrote. For those of you who are familiar with WebRender, I basically ripped off Pathfinder 2. The idea is that you take the curves that make up each glyph and turn that into trapezoid. I need to say this correctly, I always get this wrong. You turn it into trapezoids, and those trapezoids you can then further break up in a triangle and a rectangle. 2 triangles and a rectangle, actually. the rectangle you can just render to the screen. The triangles you render with a special pixel shader that measures how much of the triangle intersects with this pixel. And that amount of intersection determines your anti-aliasing. So that's how we render the glyphs. That gets rendered to a texture atlas. And then basically, because it's all monospace, every letter you see here is just a rectangle that instances something from that texture. Oh, we lost signal.
It's just power saved.
Yeah. Here we go.
Yeah, so also the part that I wrote is the subpixel atlasing part. So
Right.
Want me to say that? Or
Yeah, no, sure, go ahead.
So the text renderer actually uses a subpixel index in the atlas. So when it needs to draw a character, it not only uses the glyph ID, but also I think a 4x4 grid subpixel index to get the character you want. If you don't use enough subpixel indices, you will see that this text starts to look jumbled. So you just need to set it high enough that you can't see it anymore.
Yeah, so this is part of why text rendering hates you. Rendering glyphs is really hard. Like even with, well, mathematically perfect anti-aliasing, it still doesn't look very good on low DPI screens.
Yeah, so we used to actually render it in many different ways. We had a multi-channel SDF, we had single-channel SDF. I used a Glyphy for a while. It was also an algorithm, but it gets a multi-channel SDF is actually pretty fast for the GPU, but it has very nasty edge cases with certain fonts.
Yeah.
SDF doesn't mip-map very nicely because we always try to make everything work in AR and VR.
Mm-hmm.
And if you draw that in VR, it just it starts to swim. And with this atlasing, I keep a mipmap chain of actually non-power of 2 mipmaps, until it looked kind of good in VR.
So one final remark is that the reason this looks not very good on low DPI screen is not because of the rendering. The rendering is fine, but fonts are so small that what you really need to do is pixel hinting. So most fonts come with a bytecode program built in. It's actually a bytecode program that tells you how to offset each curve of each glyph at a certain resolutions. And that's something we don't do because it's a lot of work. Something we'll have to do eventually in some form or another. So does that answer your question?
Yes.
Great. Anything else?
Oh, other side. Was it here?
Yeah, it doesn't matter. Based on your algorithm, if you change, let's say, one character, you do a complete re-render of your entire document?
Yep.
Or
Yep.
fast enough?
It's fast enough because you only render the part of text that's visible. So it's the virtual viewport that makes this fast. If I would render the entire document, you would start to notice some slowness.
Yeah, but your algorithm, the computation of heights, etc., right? It's you need to do that layout phase in any case, right?
So for the height, no, because I pre-cache that. That's the summed height stuff I talked about earlier. For the width, currently, yes. But the layout algorithm is really simple. The word wrapping I mentioned earlier, I compute that up front, right? So I already know where all the soft word breaks are. I just need to iterate over all the elements and keep track of the column, which is a fairly fast process. Yeah. You're currently looking at a 20K line document. So even with that...
So if you change a character and something changes, you just invalidate everything, all your caches and you...
Well, not everything. So if I change a single line, then most of the time I just invalidate everything I've cached for that single line. Cool. As long as the height of the line doesn't change, so if you don't press enter or you don't change the word wrapping, then everything below it is still valid.
Which is most of the case, of course.
Which is most of the time that's the case. But if the height of a single line changes, everything after that needs to be invalidated.
Clear, thank you.
Yeah, and just to add to that a bit, the last part of this is going to be async integration with tree sitter and what is it? Language server, Rust Analyzer.
Rust Analyzer, essentially.
Yeah. So these things stream annotations in async, and yeah, so
Yeah,
this
so-
is designed to deal with that, but
Yeah.
it's still work in
So
progress.
we haven't fully worked out the plugin model yet, but the idea is to have something async. So whenever the text changes, I will send a diff over to the plugin, which can then update its representation of the text and generate annotations, which it can then send back to the main thread. That's the basic idea so far.
Okay, any other questions? Here?
Wow, a lot of questions.
Yeah, I was just curious. You mentioned that you use pixel shader. So are you actually going through a traditional rendering pipeline, or are you actually doing all compute?
There's no compute
Because-
shaders.
No compute
No,
shaders.
it's all pixel shader, vertex shader.
But why?
Mainly browser compatibility. All of this stuff also runs on the browser where you just have WebGL.
Ah, okay.
And I think compute shader support is kind of coming
Yeah,
now,
yeah.
but by the time we wrote this, it wasn't there.
Okay.
So yeah, we really couldn't.
Fair enough.
Yeah, and also, embedded Linux, older Androids. Compute shaders are not as readily available everywhere as you would want.
So even if we did have them, we'd need a fallback.
Yeah, we would probably not use much of it for at least another 5 years or something. I mean, not for this problem. Like, there's not much to be gained from using compute shaders for this. Like,
Yeah.
I mean, I don't see which feature we could do with compute that we can't do now.
No, me neither, to be honest. Like most of our rendering already happens on the GPU. So
I don't know where it's.
Yeah. Okay, anybody else? Yeah, here you go.
So you mentioned the XC editor.
Yeah.
And I believe it uses some fancy. I just googled it. Rope presentation.
oh yeah, it does.
I didn't look into it at all, so I don't know how it works. Is it roughly like you're doing, or totally
No,
different?
No, and deliberately so, because I looked into it
Mhm.
and actually implemented a rope, very similar to Xyz, but it makes everything else more complicated.
Okay.
For instance, like where does each line start in the rope? You need a separate data structure for that. And you'd think that is easy because you can keep some auxiliary data with each node in the tree. This is called an annotated B tree, I think. Don't pin me on that. Anyway, that works as long as every line break character is always a single character, which is not the case in an editor because of Windows. Yeah, so that's just one of the problems I ran into with that representation. And given that we have limited resources for this, I was like, no, you know what? I'm going to do a line-based thing because that's going to be more than sufficient for 99% of the use cases we have. And it's just so much easier to implement. So yeah, looked into it, and it is more efficient, obviously. Like for large documents, doing edits in a rope, especially if you have long lines, then the rope will outperform this representation.
Will one day the editor support the rich text rendering, just like the document like LaTeX?
No. Again, that's a deliberate design choice. If you want to do full rich text rendering, that is a whole another can of worms. At the start of this talk, I said like we were making a number of simplifying assumptions, right? Right.
Yep.
We only have monospace fonts. As soon as I let go of that, then the whole grid layout system no longer works. Because characters can have different sizes, different heights. Everything becomes more complicated. I might look into this as soon as we start building an HTML renderer for Makepad. But for the code editor, no, this is not something I'm planning to do.
Thank you.
Yeah, just to add to that a little bit, we looked at a lot of rich text editors, specifically also for code. Like I think Microsoft had a prototype, sort of a very hybridized code editor with everything variable sized, and it just gave me a headache. It's like it is very hard to see the utility of letting go of a grid, and we also want to get this working sometime in the near future. So I think it's a defendable choice not to do variable-sized fonts.
Yeah, I mean, if you're building Google Docs, then obviously rich text setting is what you want. But if you're building a code editor, I think this is a fair compromise.
Okay, thanks. Anybody else?
Wow.
I wonder, like, what are the performance bottlenecks of this editor right now?
Performance bottlenecks.
What are you maxed out on here? Like, what's
So hard to tell. Just before this talk, I realized I was word wrapping on every frame. So that really slowed it down when I switched it to a 20K line document. So I just fixed that earlier. I think the other known thing is actually recomputing the width of every line on each frame to figure out how large my scroll box needs to be.
Did you show word wrapping?
Oh, hey, good point. So that's actually the coolest feature. So
Because this is our third editor, and the first time I made an editor, I of course was like, word wrapping? No. So I was like, Eddy will do that someday, and this is that someday. So
yeah.
While you're demoing, I also have a sneaky question. Can you increase the font size?
I could by recompiling the thing, right?
There we go.
It only takes 10 seconds, right? So.
Which we can do, by the way. Let's see, Rick.
you see, Eddy uses VS Code, which is I had a deal with Eddy. Like he would leave VS Code if he could make his own editor, and that's also what is happening now.
So, Rick, can you quickly remind me how to increase the font size here?
No. What was it again? See, that's what happens when you evolve UI framework over the course of 5 years. You forget your own notation. Because it's like, which version is that again? Why don't you continue with something else whilst I look it up?
No, sure. We'll see if we can get this to work. Any other questions in the meantime?
So I have a question, right? Does
Yep.
it support Vim bindings?
Nice. I mean, it's good.
No, I was thinking of using escape to do code folding, so that's
Yeah,
going
so
to be
Rick
a
already
very
knew that
conflicting
idea.
requirement.
Control-C works too.
There you go. Well, there's no real reason that it couldn't. I mean, the way the input works is all up for grabs. But currently, no.
Okay, what are the next features you're looking at implementing?
Oh, man, I have tons of stuff I still need to do.
Eddy, it's just font underscore size with a value.
And what does that value signify? Will this bork it completely?
Yeah, it signifies something that makes it bigger when it's bigger.
Okay, okay, that's fine. So this doesn't do much. Are you sure it's font size? Oh wait, I'm an idiot. That's. Oh wow.
Wow.
I don't know. Don't know what this does, but.
No, that doesn't look good.
I'll just keep asking the question every time we forget.
Yeah, do that because challenge accepted, my friend.
See, this is why I do the recompile demos, because they,
Yeah.
they do.
Next time I need to prepare this. So anyway, sorry. Back to your question. Sorry, quickly remind me.
Yeah, features.
What features? Yes. So undo redo. I don't have that yet. I already know how I'm going to implement that. It's fairly straightforward. Auto indenting. That's a thing. Because right now, if I paste something, it just literally pastes the text, which is never what you want. Let's see what else is there. Automatic parent injection. So whenever I type an opening bracket, I want the closing bracket to automatically appear. So basically lots of stuff like that. Basically, I still have a long ways to go to make this an actual nice-to-use editor. Search is another thing, specifically regex search, which I use a lot. So
This is why I also made a regex engine.
don't mention that stuff, Rick. So, yeah, so off the bat, those are some of the features on my list.
Yeah, cool. Awesome. Very nice presentation, guys. Thanks.
Thank you.